started. So this is a discussion session talking about a proposed lead project called HAL Unification in Android, or Android consolidation. The goals in it is similar to other talks, getting mainline kernels working better, applying what we did in the kernel side on kernel consolidation to HALs in Android. And so I just have a few slides just kind of describing describing the problem and the goals, and then we'll get into kind of the areas that we're going to work on and discuss those. So what is the problem? So today, to support Android on a platform, you have to build the entire stack from bootloaders, trust zone, kernel, HALs, and build the whole system. And generally, it's build the complete stack for every device, one by one. So how you support that varies if you're supporting one device, two devices, or what if you have 96 different boards? How would you support that? And that would have to change at some point in there. Where that is, I don't know, probably 10 to 20 board range is where you would start to not be able to support that model. Major problem that all the discussions seem to come back to is there is no upstream for Android. There's AOSP, but for the device side, there's no community around it to create common HALs, common infrastructure to solve some of this. And then since there's no community around the HALs and the kernels are vendor kernels, kernel ABI is basically ignored, and kernel driver interfaces get extended in fun and interesting ways. So what are the goals of this project? Today, if you want to support Android plus another Linux distribution, you generally have two different teams and two different sets of software you have to develop. There's some commonality in kernel, but like for graphics, you're developing X drivers for Chrome OS, and you're doing hardware composer for Android. So part of the goal here is to get to where you develop your support once, primarily in the kernel, and it will just work for Android and other Linux distros. Getting mainline kernels to work out of the box, eliminating the need for custom HALs. So there's reference HALs in AOSP. They're often just copied to a new device and hacked up till they work with that device. Getting those HALs to be more dynamic and extensible enough that there is not a need to create a HAL. You can just take it as is, and it works out of the box. What will that, and so all that kind of leads into making it easier to add new devices. You have a new board. If the kernel support is there, bootloader support is there. You just are able to take Android as is and put and go. And finally, goal here is to create an upstream community for Android device side. So there's a long list of HALs that I haven't covered here. They probably all need work in some way or another. So in our discussions around this, one thing has been a clear top priority, and that's graphics and moving to DRM for graphics. Wi-Fi and Bluetooth is another area that's being worked on. We'll go into that in the next slides. Then there's also a couple of areas that are kind of low-hanging fruit that we identified, which are vibrator and the lights HAL. And as an example, in lights, I think there's 3 lights HALs for Qualcomm-based devices, I think it was, that are essentially just copies of each other, and the only difference is sysfs paths in the HAL. The other area that we're looking at is build system and how to make improvements around that, making it easier to add devices, supporting multiple devices in one build, and so forth. Okay, so for DRM, there seems to be a consensus across different companies and groups that DRM is the way forward. Even Google is in agreement on that front, I believe.
I would give it a hard argument.
There are people within Google that agree that this is the way forward. So the challenge there is there's still some gaps. Some of the major ones are solved with the atomic mode setting. The challenge is that to add features specific for Android that upstream DRM maintainers require that there's a open user space that is utilizing those features, as well as it can't just be a kind of one-off experiment example. It needs to be, quote, production user space. Would you like to add to Plummer's discussions?
No, I think, so yeah, at Plummer's, the biggest thing that got discussed was the state of atomic mode set at the moment. And then how, of course, the good thing that we've seen is there are a few of our members and few of people outside who have a DRM-based, not hardware composer as well, but even DRM-based drivers for display. That was a problem maybe a couple of years ago, where everyone had their own display driver mechanism. And at Plumbers, I think the biggest thing is what you've already covered, which is that sort of all of us seem to agree that if we can have one DRM-based hardware composer HAL that people could use, I mean, this could be the mostly working one. Of course, there are many of the DRM drivers add custom actives for performance reasons and so on, and that is still all right if you're able to give out or let people use one DRM hardware composer HAL with which works for everyone, and then if you want performance, you go to just another HAL. Yeah.
Yeah. One other issue here is I know one of the kind of design goals with ADF that Google had was not just in order to get this extra functionality, but to make it easier for vendors to do the right thing. So since Google tends to interact with a lot of vendors who have proprietary solutions and binary blobs, they can't just go in and fix it. And so they want to kind of close, I guess, the path, so the easiest way is the right way. With DRM in the kernel, we may need to try to do some assistance in order to make sure that vendors who are moving to DRM are also doing the right thing, because it is a lot more flexible and it wants to avoid having mid layers that simplify things in that same way. So,
yeah, and one thing I've noticed, having looked at DRM quite a bit in the kernel lately, there is a lot of duplication right now from SOC driver to driver, and there's work around there to kind of pull out common bits and make it more just here, fill in your hardware specific bits. The device tree bindings for the display stuff is kind of all over the map. So that's an area that I've been looking at. Yeah, so there's various DRM efforts already. Linaro has hardware composer for DRM. It's supported on, I think, ST and now high-key platforms. There's Android x86, which is, I guess, a Android for PC version of Android that supports the various Intel, AMD, NVIDIA graphics on PC hardware. Then there's been some work with Fredrino they've taken the Android x86 support there. As well as, I believe TI has a DRM implementation that they talked about at Plumbers, but I don't think that's publicly available yet. But they did express willingness to make that public. So we had some discussions this week. I think there's kind of a plan forward how to move forward on that. You want to summarize?
yeah, I'm not sure if we have exact sense of the next steps exactly, but we're going to start looking at the different implementations that people have made available and trying to find a way to find some neutral territory that we can kind of share. So likely something like a GitHub project where we basically set up the needed Git repos that are needed to replace a graphics HAL. And it may be something where we start with the Android x86 stuff and then try to supply the changes that Linaro has in their hardware composer to try to unify those two. But to some extent too, there's a lot of, I guess, device-specific code as well, and some things that need to be moved into Mesa from, I believe, libDRM. And so there's kind of further cleanup just in general that needs to be done as well. And so trying to figure out exactly whether we're going to do that cleanup first or start up the projects first, I'm not sure yet.
Right, and so that work will probably start on Dragon boards 410, right?
Likely.
Which has one challenge that's Code Aurora based right now for the builds, so we need kind of mainline AOSP based build for that.
That's something you're already sort of working on.
Yeah. So essentially, we have a system image now that has Fredrino integrated and everything, but so far we haven't been able to get it to boot, but we've only had it finished last night, so if we are really lucky, you can take a look at it in the demo sessions, but I don't think we'll be that lucky, so probably sometime next week.
And will we have that documented somewhere, how to kind of get started?
Yeah, I think we can document it.
Yeah.
Once we have something.
I mean,
Right.
we also
Obviously.
make a build available on the Android build server.
Okay. So kind of, I guess for our hardware composer implementation, one of the first things up is adapting that for atomic mode setting. Do we have idea how much work that will be? Or?
So I'll probably sit here and we can share the mic. So I think that right now the challenge there is that most of the hardware composer implementations are older kernel based, and atomic mode set went into 4.3, like with a reasonable feature set. So if maybe the first channel would be to have these whatever devices work with mainline kernel, and then in parallel have a hardware composer adapted to atomic mode set. It ideally should not be a huge task, but I think that's something we are still investigating.
So what kernel version is the
That is
Dragon board build?
4.0.
4.0.
Okay. So that's probably another task, is to move to 4.3 or.
Yeah, but that's a task for a landing team.
Yeah.
According to the status, it's almost all upstream with just a few patches.
High Key also will be probably having some similar efforts, so
Right.
I suspect we worked in parallel, so.
Yeah, except graphics. So.
Well, yeah, on the binary side, but yeah, at least the.
Yeah, right.
Then kind of, once we get past that point, it's starting to add features, which is the main feature is Android sync fence support. So I get the sense that, Rob Clark's not here, but I get the sense that he has ideas around how that would be implemented.
Yes, so we have spoken with him. So if we step back a little bit, right now you have, so there are two parts to it. One part is the fence versus sync points thing. If you really want to use sync points in mainline today, I mean in staging today, sync points use fences underneath. So the above fences are already in use in that path. And then the other aspect is to have your DRM drivers, which is both the display bits and the graphics bits, to use fences at the moment. So
And also the video codecs, right?
I'm sorry?
Also video codecs can,
Yes. So probably that's the first.
right.
Yeah. But yeah, so there is some talk with him, but I think right now even Fridreno doesn't seem to support fences in the main line. I'm sure he has certain plans about it, but
I know Intel's been looking at this a little bit, but it's not clear if anybody's focused on it. Apparently even folks at Google are even starting to kind of look at how they might integrate, fences and DRM. So that's.
Yeah, and speaking of Intel, we need to figure out how to work with Intel on this as well. 'Cause as part of having an upstream that's for new features in, that they're a part of that mix. Then the last thing here is there's the DRM test suite. Currently, it's called Intel Graphic Tools. So looking at that, seeing how much is really Intel specific versus DRM generic, and trying to get testing working there. One of the comments at Plumbers was that all the ARM DRM drivers are crap. Well, anything else on DRM we should talk about today?
So if any of you guys are from our member teams and you have any ideas on, first, if you have DRM drivers, and then you have any ideas on it, please feel free to ping John or me. And I'm Sumit, John's tools. So please feel free to ping us, and we'll try and work together on this, because anyways, it's the consolidation effort. So it really helps if while we're starting to work, if we get ideas and concerns or issues that you might have seen already while trying something out.
Yeah. So the next area is Wi-Fi and Bluetooth drivers. Typically, well, for Broadcom, there's Broadcom vendor driver in AOSP. Most devices use a vendor driver. They don't use mainline-based Wi-Fi or Bluetooth drivers. Kind of first step there is just getting mainline to work out of the box. There's relatively simple changes to do that, assuming the Wi-Fi driver itself works, which can be a challenge. Then identifying gaps in mainline Wi-Fi. We've looked at this some already. It's things like switching between AP and client mode, and peer-to-peer support. There's like custom ioctals for Chromecast, I think.
Or the Miracast, another, running display over Wi-Fi is very customized right now. So.
There's also like the firmware for the devices on Android are often different than the mainline drivers. I think sometimes perhaps optimized for power management versus performance. And then there's also the redistribution issue. More on the Bluetooth side is UART slave support. We talked about this in Tim's session, as well as the kernel consolidation session. This is basically moving the Bluetooth vendor-specific parts and kind of glue of GPIO lines and regulator control into the kernel and having proper drivers there, rather than exposing just a UART device to user space. And this will help kind of unify the firmware download interface and kind of get rid of the glue drivers that are just doing GPIO controls in various ways. Some cases there's line discipline added to TTY. Sometimes there's RF kill device created. And this also is useful for some NFC devices, I think, are UART based, and as well as GPS. And also learned this week that Tim is working on a similar effort.
Well, I'm describing a similar effort.
Yes. Well, trying to get funding for doing this effort.
Yeah, I am looking at trying to organize something here, but.
So last up is kind of what we're thinking on build system improvements. So right now there's at least 10 to 15 Android builds, I think, within Linaro. least that I know about. Probably more that I don't know about. So it's kind of, we're looking at how to clean up our own house first and get to single system image across devices. That's probably different HALs initially, and then once we have that, we can kind of look at unifying the HALs. It's also, I think, aligned with the direction Google is moving. So in Android 1, they've added vendor, ODM, OEM partitions that kind of separate out different parts of hardware-specific stuff, and they're looking to have generic Arch system images, so generic ARM64 system image.
So a dumb question, Rob. Is the HAL versioning the same as? So is the HAL versioning the same as the Android versioning, or I mean, how does Google do HAL versioning?
How's the Windows that they're supported for? So basically, usually they'll support older HAL versions for quite a while on newer releases.
The HAL version is expected to support two major Android releases before they will have newer HAL versions, but they at least support like 2 older versions of the HALs.
And there's also already a feature in AOSP that's to pick which HAL you use, and so it has logic in there to, I forget which property it looks at, but basically which device you're on. So it'll look for audio.thatdevice.so file for the HAL, then it falls back to, it's a different property, the chip, I think, level, and then it falls back to a default after that. So we could, other than maybe falling back to the default, I don't think that feature is really used in most builds. But we could certainly utilize it here. Lots of things today are pretty static in the builds on Android, so in various HALs, we want to look at making the configuration more dynamic. This also overlaps some with the Project Ara work, where we're adding support for hot plugging of devices. And we have similar issues there that the configuration is today static. Other areas, better configuration tracking, so there's a lot of boilerplate settings that you have to put in per device. There's multiple settings for a given feature, and it's can often, if you miss one, you will not enable the feature correctly. John's suggestion has been kconfig for Android. There's also so some of the changes Google's making there are starting to show up in AOSP. It's called Blueprint. It uses the Go language to describe, it adds another layer of build configuration. I don't think it's really, the infrastructure is starting to show up. I don't think anything is using it yet.
It's even also my idea for kconfig for Android is kind of maybe more idealistic, and more realistically, I know, for example, the Intel guys have a very similar method where they just have, basically for every device there's just a file that they provide, and then they have their internal infrastructure inside of their device directory that kind of runs through all the different configurations from that one file and generates the board config and device MK files. So yeah, there may be kind of not quite as grandiose approaches as well that can kind of get similar functionality.
I don't know how much you've looked at it, but do you think it's something that is usable where you have larger variations that we have in the ARM world?
I haven't actually gotten to see it because they haven't made it public yet. They just discussed it at Plumbers. Yeah, as soon as we can take a real look at it, it's something. At the same time, even with the while they may have an easier time and be able to have kind of bigger chunks of stuff hidden under a single config option, splitting it up to be a little more granular probably isn't going to be that impossible. I feel like the kernel does a decent job with this, and it's not that difficult.
Right.
Integrating something like kconfig into Android is going to be very difficult, but the overall maintenance and managing of it, I don't think would be problematic.
Yeah, I think that may have to be something that's kind of outside of AOSP. So like one example I have here is like every device sets the compiler flags for its build, and of course if you have a Cortex A15, you want to build with your CPU set to Cortex A15 for best optimization. But then if you're working on multiple devices and they have different compiler flags, you end up rebuilding everything. And as a developer, you may not care what your optimization level is for just doing development. So if we can kind of pull out some of the stuff that's not really specific to a device, that will make switching devices less painful. That also helps on the last item, which is improving build times and getting to a generic system image helps there as well.
There is work being done inside of Google already on the last item, so that's the new build system that they've got. I don't know, not yet announced, but it's public. Should be optimizing a lot of the overall build time and minimizing the amount of time we have to spend scanning make files. So.
And it started showing up in the master.
Yeah, that's the blueprint, I think.
Yeah, the blueprint and Ninja stuff. It generates the static makefile. Your incremental builds are much faster now. It doesn't scan all the Android MK every time.
So is it actually using it?
Yes,
No.
yes. I mean, it was disabled, and like the first day of Connect, they've enabled it on the master. Not very sure if it will show up on Android M, but they've pushed it in master.
I'm pretty sure it will only show up in N because the timing at which they released it is pretty much consistent with OK, M is done.
So how much does that affect like how you create a device, or is it?
I mean, it doesn't affect the way we do the device configuration. It's just a kind of replacement for the make calls that we do.
So it's all kind of in the infrastructure and
Yes.
hidden away?
Yeah.
Okay. We'll contract Matt Porter.
Blueprint a language? Is Blueprint a language?
Well, I guess
I guess Blueprint is how they're using Go. Go is the language.
Yeah.
All right. Any other topics we should discuss today?
I'm not very sure if AOSP, but at least till now they have not shown the infrastructure on how the vendor partition gets created. I'm not sure whether they plan to push those things we should look at it.
Yeah, that's one.
Come closer, so for the video, it doesn't.
Yeah, I'm not sure as far as the Android 1 partitioning style when they're going to announce that or have good example references. I don't think, you know, while I know the Android 1 kernel is public, I don't know if the Android 1 user space has been put into AOSP. So, you know, that may be something yet to come. That may be something we never really get to see. But I suspect that AOSP will probably have similar modifications.
The /vendor part is already there, I think.
Yeah, that was for the Nexus 9, so that was
right.
done last year. But you know, for the newer stuff, I don't
although I think it was somewhat incomplete from what I remember Michael saying.
Yeah, we still don't have any infrastructure on the backbone to start pushing HALs to vendor partition kind of thing. That's something
Right.
we need. Yeah.
And part of the challenge with the vendor partition is how you build the vendor partition, right?
Yeah, that's the thing.
It's definitely, you know, the number of bugs that you can run into if you think you have, you know, the same library in 2 locations that, you know, in the vendor partition and not. So I feel like, yeah,
right. And
this is an area that I feel like we need to take our experience and as we kind of try to work in our internal trees, try to document really well, because I suspect that this is something that everyone's going to just have to, you know, learn as they partner with Google, and no one else will get it.
And the other aspect is updating them independently and not breaking ABIs there.
Yeah, I'm sure that's going to be interesting, but.
Questions from the audience?
Can you have it next week?
So
Sure.
So
I'll do it Monday.
how much are non-Linaro developers affected by this? I mean, I'm trying to think if this applies to Sony.
Everything we do affects that.
No, but I mean, no, but I mean,
We are the center.
specifically, is there a pain point? I mean, I'm trying to think how often we build for multiple devices, a single developer is building for multiple devices. It doesn't seem that often.
So in a lot of ways, it's more a developer feature than interesting for end products. I mean, kind of like single kernel image, right? It's been very helpful on the development side. But how many products really use that? And it's useful in the traditional Linux distribution case with Debian and such, but in the end product, well, customers aren't shipping mainline kernels and end products, so.
Well, one thing I might ask is just so how much is Sony using kind of, do they use individual trees for each device and they update and manage those all separately? Or is there any sort of consolidation in the build system that you guys have so that you make one fix for something like stage fright and then roll out 7 builds?
I do not know.
Okay. So I mean, that's the sort of thing, is that if you guys either have a solution like this, we definitely are interested in.
I know what we do with kernels, but I don't know what we do with the AOSP.
But yeah, so if there is a solution like that you're using, you know, interested in trying to make sure that anything that
I mean,
is working on is compatible.
Potentially, if it helps developers, but
But you know, the idea that it just helps device updates, because
Right.
you can, you know, hopefully consolidate your build system so that you have one source repo that you need to make those changes for, and then it's just a matter of building in QA rather than.
If you're not having to change the HAL and there's a HAL available that's tracking mainline and tracking all the updates, then that makes your life easier.
Yep. And eventually supporting new devices may not require new builds, which would be kind of amazing. But maybe not. That's very, very ambitious.
We're just crossing our fingers that R is going to fix all that.
Yeah.
Yeah, well.
You gotta have your Walkman module. You gotta have all sorts of things.
All right, I guess that's it. Thanks, everyone.
Thanks.